Fixed and modulating metering devices. Fixed metering devices have a specific diameter of an orifice, and you can change that. So they have drill kits that you can buy for refrigeration orifices, and the same drill kits you use on gas orifices for gas appliances. You can change the diameter, or you can just buy or get one from at the same size. All the units that I've installed in the past, if I needed a metering device, which was a fixed orifice type, all you have to do is go to the supply house and ask them for one. They give it to you. They got many of these things, and they're very inexpensive to manufacture, and they want your unit to run the best it can. So they really don't charge you for these. You could just ask for one. And they come in all different sizes. The good thing about these, there's few or no moving parts. They do have filters and screens before them so they don't get clogged. I put in a unit outside, and mixing it with a different size coil inside, I upsized the the inside unit so it would be a little bit more efficient. Well, when I was installing the outside unit, I got a little grass seed. Now, when I say this is little, I mean it's smaller than a grain of rice. And I think I got it in, but it could have came in from another source, maybe in manufacturing. But when I started using started up the unit was running really high head pressure, and I couldn't figure out what was wrong with it. Well, normally it's the metering device or kink in the line that causes that. So I shut down the system. I pumped the refrigerant back to the condensing unit. I took apart the metering device upstairs, and there was this little piece of grass seed. Have you ever seen a caraway seed? It's much smaller than that. Was stuck in that fixed diameter orifice, causing the high pressure. So they do fail, and they do have problems, but if they're put in properly and they're screened before you get to it, you should not have a problem with them. The problem overall with the fixed orifices, they do not have the high efficiency level that you get with a thermal expansion valve. It's always the same. It always lets the same amount of refrigerant through it. So some refrigerant gets wasted in these cases. Modulating meter device changes orifice size to account for the change in cooling load. It opens and closes. It just operates better. It's more efficient. But they are problematic. They can go bad. A fixed orifice device will never go bad. It will always work as long as the refrigerant going through is clean. Capillary tube device. Here's a capillary tube, and it's hard to understand how thick this is. But this capillary tube is about, the outside diameter is about the size of a number 2 pencil lead. It's very small. It's actually maybe a little bit smaller than that. The opening inside, there would be no way if you had a small 1-inch piece where you probably could even see light through it, because it's so small inside it'd have to be ultra straight to get through it. But it is another thing that these have worked for many decades, and this is what we started off with. The problem with this tube, though, is it plugs very easily. So any debris gets in this line at all will cause this tube. The good thing is you might have 8 of these tubes on an evap coil in an attic or in the air handler outside or wherever it happens to be. So if one gets clogged, you still have 7 others that will work, and you might not know that one part of the coil is not working until you touch that coil with your hand. You feel a spot on that coil that's not as cold as the rest of it. That capillary tube probably has a problem. They also may have functions in the liquid line, conduct contacts with suction line to function as a heat exchanger. A lot of metering devices, for example, you'd have a capillary tube in most refrigerators running around the door, the inside frame of the door, not the actual door that swings open and closed, but the box that the door closes on. It runs around that. So you're always pumping high temperature refrigerant around that door, and you're saying, why do they do that? Well, your freezer door would freeze shut. If any moisture going in would get trapped on that door seal, you shut that door, it gets to be 0 degrees inside that freezer. Your freezer door you wouldn't be able to open. So they put a small capillary tube running around that door frame That way, when the door's shut, it stays warm. It doesn't get to 0 degrees and freeze. But there's other things that the capillary tubes use in refrigeration and cooling. Capillary tube diagram. Again, it's a little bit easier to see in your book on page 474 in Modern Refrigeration 20th edition. And you can see the way it works. Capillary tube capacities. It all depends on the length of the tube, the inside diameter of the tube, and the number of turns. And you're probably thinking, well, if the tube is the same size in the inside when it goes around the turn, why should that matter? Well, like anything, bends take a little bit more work to go around. You're like running into, when you have a 90-degree bend, either on airflow in your ductwork or capillary tubes or water flow in your home, a 90-degree bend, that item, whether it's air, refrigerant, or water, has to change direction. And it hits that other end, that other side of the 90, and it doesn't make a smooth turn. It kind of runs and then pushes. Think about running down a long hallway as fast as you can, and you come to a 90-degree bend. Well, if you don't hit that wall, you're not going fast enough. So it's hard to make a sharp turn. So you will lose the amount of refrigerant. You see a lot of these coils coiled up because when they design these, they can't tell exactly how it should work. But you could actually put bends on a capillary tube to make less refrigerant go through. So there's ways that you can tune a system as well with a capillary tube. Capillary tube is a chart of dimensions, not something you probably ever use in your life, but you can. You're going to buy a unit that has capillary tubes already on it, or if you have to replace those capillary tubes, you can get the size that you need to change them out. But capillary tubes rarely get changed out. If you get a leak on one, you cut it off, and you braze it back on without that small little section. Capillary tube fittings. You have compression rings, which is normally what you see in water or plumbing. You have brazed liquid line, so you can have that liquid line coming to it. You put that capillary tube to the inside of it. You size it down. You can crimp it off and solder it. There's tube that has flare fittings that you can braze onto, and there's a special combination of pieces. The bottom one is what Trane used to use on their systems. These special two-way nuts. It's kind of odd setup, but they were the ones that used those.